So not all triangles are right triangles. There's good news. We've got something for that. Here we have the law of sines. Now, first thing to pay attention to, if we're talking about angle A is here, then opposite of angle A is what we're going to call side A. Opposite of angle B is side B. Opposite of angle C is side C. Now, just like you did in geometry, these vertices around here, these points, are labeled with uppercase letters, so angle A, angle B, angle C, those are uppercase letters. The segments are lowercase letters, and they will always coordinate with one another just like this, where we have our angle, and then opposite that is our side. And that's what we really have to pay attention to with law of sines, because we're basically setting up a proportion, and we're going to say that the sine of angle A is to side A as the sine of angle B is to side B. Or we could also have on there then the sine of angle C is to side C. But we're saying that the sine of the angle, that value compared to the side length, we're giving a ratio, and that it would be the same for all of these. So to use that, here we have a triangle. We're given that angle A here is 35 degrees, angle B is 15. Now, of course, to find angle C, triangles have to add up to 180, so then that would make angle C 130 degrees. Now, as far as finding sides A and B, now we're setting up that proportion. So we could say that the sine of 130 over 5 would be equal to, and now we could either solve for sine of angle A over A or sine of angle B over B. So we're going to say sine of angle A, which we know is 35 degrees, and then we're looking for A. And so from here we treat this just like a proportion. We can plug in our decimal values first if we want to for that, or we can cross multiply and solve, in which case we're going to say 5 times the sine of 35 gives us this value, and then we're dividing that by the sine of 130 degrees. And so we find that side A would have to be equal to 3.74 units. Then we could set up a similar proportion to find side B, in which case we could say sine of 130 is to 5 as, remember angle B was 15, so then sine of 15 is to B. So again, I'm cross multiplying, so I'm going to have 5 times the sine of 15 is equal to B times sine of 130. Divide the 130 over, so it would be similar to how we solved this first one. So again, 5 times the sine of 15 degrees, make sure you have your mode in degrees. Take that value, and then we're dividing by sine of 130. So now we can see that side B is 1.69 units. And obviously the longest side has to be opposite the largest angle, smallest side is opposite the smallest angle. Now we have another scenario that comes up. Remember in geometry when we were talking about shortcuts for proving triangles congruent, we had one side-side angle that does not work, because when we did the investigation, there's more than one triangle possible. And so if you were in my class, I told you to remember that by saying no swearing. Well, here what we're going to do is we're going to actually try and figure out what those two triangles look like, because we can use trigonometry to then figure this out. First thing we need to do is to determine if there's actually two triangles. So what we're given is we're given an angle and then two sides. And so if we were to sketch this out, we have our angle A of 35 degrees. So here's 35 degrees, here's angle A. Now side B is adjacent to that, so we'll say that is 8 units. And let's just imagine for right now that we have a right triangle. And so we're going to say this is our height. So if we use sine of angle A, and we look at this opposite side, so we have sine of 35 is equal to opposite over hypotenuse, so that's h over 8. We could figure out what our h value is. We'll take 8 times the sine of a. Alright, and we'll plug that into the calculator. So we have 8 times the sine of 35 degrees. And so if this is a right triangle, then a would need to be about 4.6 units. Or excuse me, h. 4.6. So when we look up at this value, if it's greater than that, then this is going to make at least one triangle, maybe two. If it were shorter than that, then this piece, this leg, would just swing there and never intersect this side. So imagine if this a value was only 3. Then what you would end up with is a segment that is 3 units long that would never intersect this side, because the shortest it can be is 4.6 units. So that's our first scenario, is that if side A is less than what you just found for that height, if it's less than h, then that means there's no triangle. Now, if our A value is bigger than our B value, if A is greater than B, now as we drop that off over this direction, if it were 9, then that's going to make a triangle, and it's going to make an obtuse triangle. And there's only going to be one triangle. So it would make one obtuse triangle. And that angle in between A and B, sides A and B, would be an obtuse angle. Now here's the other scenario, and this is where we're at right now, because A is not bigger than B. A is smaller than B, but it's bigger than H. So if we have our A value greater than H and less than B, then what's going to happen is as it swings around here, it's going to intersect in two different places. And we're going to have two triangles possible. So that's what we're going to look at now. So what we could have is possibility number 1. Here's our 35 degrees. Here's our 8. And this is going to come out this direction, and this will be 6. Or possibility number 2, again, this is 35. Here's our 8. This is 35, and this is going to come back in this direction, and this will be 6. So you can see back here, we're saying it'll come back this direction and be 6, or it'll come over this direction and be 6 to make these two possible triangles. So now from this point, we're just going to solve for each of these to figure out the other parts. So let's see, we had angle A here, and then this is going to be angle B because this was side B, and then angle C up here at the top. So the first thing we would do is we're going to solve for angle B. All right, so if we take sine of 35 over 6, and then the sine of angle B over 8, and we'll solve for B. Now remember, right here we're actually looking for an angle, so we'll end up doing the inverse sign. Anytime we're looking for an angle, it would be inverse. So we'll have 8 times the sine of 35 divided by 6. So there's our decimal value. We then take the inverse sine of that value. So I'm hitting second and the negative key. That plugs my answer back in. And I can find that now angle B is about 49.9 degrees. So in this triangle, angle B is 49.9 degrees. So then I can find angle C. Triangles add up to 180. So if I take that plus 35, then we have our 180 minus that. Find that angle C then would have to be 95.1. And now we can use law of sines to find our other side. So then we can set that up as sine of 95.1 is to side C as sine of 35 is to 6. Cross multiply and solve. And then we would find that C is about 10.4 units. Now back to our other possibility. Now if over here we have an angle that is 49.9, remember right back up here at the beginning when we swung that over, we're saying this angle is 49.9 degrees. If we swing that over, what we've basically made here is an isosceles triangle. So that means this angle here is also 49.9. So the other angle B is the supplement to the angle B we found right here. So in our second triangle, to find angle B here, we take 180 minus the angle B we had here in the first place, 49.9. So if we take our 180 minus the 49.9, find that in the second triangle, angle B is 130.1 degrees. Which then, now we can find angle C, because triangles add up to 180. So if we take our 130.1 plus the 35 for angle A, and then 180 minus our answer, find that in this scenario, now angle C is only 14.9 degrees. Now to find side C, again we use law of sines. So sine of 14.9 is to side C as sine of 35 is to 6. Cross multiply and solve, we find that in this case now side C is 2.7 units. So that's how we can solve. Anytime we have a side-side angle scenario, we can solve for both of those triangles.